Dear colleagues, I would like to draw your attention to our article called Air Navigation, the Method of Airborne Vehicles Classification based on Fuzzy-Colored Petri nets. This is a joint project of several scientists teaching at higher educational institutions, united by the common idea of creating a safe space in the so-called smart cities. These scientists work at Lomonosov Moscow State University, National Aviation University in Kiev, and Vernadsky Crimean Federal University. The reported study was funded by Russian Fund for Basic Research, project number 192906081. Methodology for creating an air traffic control system for unmanned vehicles in a smart city is based on monitoring their trajectory parameters by multi-position location complexes with heterogeneous elements. Currently, the ideology of the use and development of airspace, the modern smart city, is due to the fact that along with manned flying vehicles, airplanes, helicopters are increasingly using unmanned aircraft, which solve the problem of moving goods, people, monitoring of territories, ensuring communication, and so on. Therefore, a reliable and secure environment is needed for the quality and stability of unmanned aircraft. The paper considers the main provisions of the theory of air traffic control for the safe integration of such aircraft into air traffic or smart city, with existing manned aircraft devices based on monitoring using heterogeneous locating tools available on territories of the smart city and newly created, which are combined into a single multi-position system, which is a source of information on air objects for the operational level of the air traffic control system. This article is part of the series of articles Air Navigation, an integrated test method for airborne objects identification systems, Air Navigation, the classification of airborne vehicles and the air traffic management system, Air Navigation, peculiarities of testing software for airborne object identification systems, and Air Navigation, the method of airborne vehicles classification based on fuzzy-colored Petri nets. In addition to the listed articles, there were also the following publications on the topic. Methodology of creating air traffic control system for unmanned vehicles, analysis of the methodology of monitoring unmanned vehicles of the smart city, methodology for estimating the potential accuracy of a multi-position statistical information measuring system, and principles of construction of the information measuring system for monitoring unmanned aircraft. Every day a lot of industrial facilities such as airports, oil refineries, nuclear power plants, electrical power lines and gas pipelines suffer from attacks with the use of different types of airborne objects, primarily unmanned airborne vehicles. At the same time, unmanned aerial vehicles are used everywhere to monitor and protect these industrial facilities. The specific technical equipment is necessary to facilitate identifying a threat emanating from a certain airborne object in the specified area of responsibility in the automatic or automated modes using the Unified Data Management System. As it may be inferred from the successful completion of similar tasks, one of the most advanced methods of developing the software for such technical equipment controlling airspace is the method of fuzzy Petri nets. In the article, the fuzzy-colored Petri net is represented by the following formula. The value of the set of airborne objects characteristics and the classes of airborne objects of the set are in a binary relation to each other and are specified by the corresponding matrix of relations. This method has proved the capability of solving multi-level tasks. Besides, it allows adapting to the peculiarities of the specified subject area's process. As indicated in Figure 2, the process of verifying the software of the fuzzy logical system of airborne vehicles classification can be generally considered as the research process into the dynamic interacting processes. Moreover, known are the specific theoretical and practical results of using Petri nets for the research into the dynamic interacting processes. These Petri nets are characterized by the following features. The capability of forming fuzzy net models characterized by natural interpretation, simplicity of description, creation of the dynamic fuzzy interacting processes presented in numerous condition-action relationships, taking into account numerous real specifications, features, factors, and limits on a certain subject area. The adaptation to classes of problems and subject areas in addressing the set of considered problems of verifying the software of the fuzzy logical classification system. And the solution of the set of problems under consideration as a unified problem of creating models, criteria, methods, and effective tools with the use of modern digital technologies. The extended fuzzy colored Petri nets have been chosen as the basic mathematical tool for verifying the software of the fuzzy logical system for classifying airborne vehicles and the process of airspace control. This class of Petri nets provides a decrease in the dependence of the dimension of the fuzzy net verification model on the dimension of the dynamic interacting processes in the subject area. Moreover, a set of fuzzy production rules of the fuzzy logical system for the classification of airborne vehicles and the process of monitoring the use of airspace and a generalized algorithm for the implementation of these rules has been developed. Structurally, fuzzy production rules correspond to the rules Sageno fuzzy logical system of the first order. The full representation of the process of airborne vehicles classification using the fuzzy logical model allows taking into account the non-stochastic and subjective nature of the decision-making process by operators controlling the airspace. The developed generalized algorithm for the implementation of fuzzy production rules within the Sageno system of the first order is the basis for creating software for the fuzzy logical system for airborne vehicles classification. The considered approach can be used as the basis for the software verification method for the fuzzy logical system for airborne vehicles classification, which ensures the transformation of the set of fuzzy production rules into a workable model based on the use of fuzzy colored Petri nets within the model of formal software verification methods. As a result of the method's implementation, there should be an analytical report on the possible strategy of the model and the identification of all possible classes of airborne vehicles, the data on which are received by the air traffic control system. So thank you for your attention.